Hello, it's me, your teacher, again. Wow, what a surprise. Okay, so following on from the previous video, and a reminder that electrolytic cells are a type of cell that convert electrical energy from the battery that's connected to the device into chemical energy, or driving that reaction to occur. So without that input in electrical energy, we will not see any redox reaction happen inside an electrolytic cell. It must be connected to a power source in order for something to occur. The features of an electrolytic cell, it is important that we kind of get comfortable knowing these things and writing about them, because one of the things you need to do in your assessment is compare and contrast an electrolytic cell versus a galvanic cell. By that point, it should be fairly drilled into your brain, but it's good to practice anyway. So features of an electrolytic cell, we have two electrodes that are placed into the same container, so they're in the same beaker. That container will hold either a solution or a molten electrolyte. So molten means that it has been liquefied by heat, and the electrolyte is an ionic compound. Those electrodes are then connected to a battery, so a source of electrical energy. The redox reactions that occur inside the cell must be non-spontaneous, so they must be ones that require that input of energy, otherwise it is not an electrolytic reaction. The negatively charged electrode is the cathode, where reduction occurs, and the positively charged electrode is called the anode, where the oxidation will occur. This here is a glossary. In class, I'm going to get you to label a picture of a electrolytic cell using these terms and definitions, but if you weren't there or aren't sure, I recommend that you write these in your book, either in the back in a glossary area or start a glossary area in your notes for this topic. So a molten electrolyte is an ionic compound that has been melted, not dissolved. So it has been liquefied by heat. So if you remember back to your level 2 structure and bonding, you might remember that ionic compounds have very, very strong bonds and have very, very high melting points. So a lot of energy is required to melt them. But the important thing is that there is no water present. There is just liquid ionic compound. The current that goes through your electrolytic cell will cause that ionic compound to break up into its two ions. The positively charged ion will then head to the negative cathode to be reduced, red cat, and the negatively charged ion will head to the positively charged anode to be oxidized, which hopefully makes sense. So opposites attract. That negative cathode is going to be really interesting to that positively charged ion, and it's going to head straight to it. And when it gets there, it is going to be reduced. And then it's going to take electrons from that negative cathode, and then the negatively charged ion heads to the positively charged anode to give its electrons up and become oxidized. This is an example of an electrolytic cell. You can see that it is inside the same container. There's a dotted line in the middle there, but that's a big beaker which has both of the electrodes in. You've got the cathode and the anode. You can see that the electrons are moving from down the wire from the positively charged anode towards the negatively charged cathode. So the electrons are moving towards the negatively charged thing, making it negative. And you can see that the positively charged sodium is moving towards the negatively charged cathode, and the negatively charged chlorine is moving towards the positively charged anode. We can see bubbles of chlorine, and we would also see a silvery metal deposit forming on the cathode.